guys, welcome back. In the previous video, we talked about how you can actually solve a titration problem. Remember that we can solve for the concentration of an unknown acid or base if we have a known concentration of the other. And so this video, what we're going to be doing is we're going to be focusing on the lab technique on how we collect the data to actually solve the problems. And what we're going to be doing a little bit different that we've not used before is a new piece of equipment that's known as a buret. The buret is this piece of glassware right here that is actually used to transfer whether it be our acid or our base into our reaction flask. So the first thing we need to do is we need to actually put our acid into our buret so we can then transfer it in. And we're going to be using a funnel. We go ahead and transfer it in. There we go. All right, so it's finally full there. Okay, then when it's in there, notice we've got a valve at the bottom. We can open the valve and then we can allow the solution to drip out the bottom. We can open it up at full force so it actually drains out quickly, or we can open the buret only slightly, open that valve only slightly, and then what we can do is we can get the solution to come out drop by drop. So once we've transferred our solution into our buret, the first thing that we need to do is we need to record the initial volume of the buret. Now, a few things to notice different here. Notice right here that our 0 is at the top and our 35 is at the bottom. And so when we read, we are reading it from the top down. Now what I mean by that is if I blow up this picture just a little bit, notice that I'm going to again read from the bottom of the meniscus. It's between the 3 and the 4. So I'm going to call this reading right here as 3.5 milliliters. We're reading from the top down. Now you might look at that and say, well, there's not 3.5 milliliters of solution in that buret. There's a lot more than that. Well, this is true. This is just a reading that we write down that will ultimately help us to determine how much solution actually is coming out of the base of the buret. So again, we filled it up. We read from the top down the initial volume and we record that into our data table. Then what we do is we open the valve and we let some of solution drain out. And then you'll notice that the volume is now much lower in my buret. And then what I'm going to do is I'm going to read the volume that it's indicated at now. And again, read from the top down. You're going to want to look at this and say it's at 17.5, but because we're reading from the top down, it's not 14, it's not 15, it's not 16, it's a little bit more than 16, it's at 16.5. And we are going to refer to that as our final volume. So then, if you'll notice up here, I've got the line where we were at initially, I've got the line where we were at finally, so it's the difference between these 2 points. That is the amount of solution that I actually released into my flask. So we're going to calculate that volume. And guys, I know it's just a simple subtraction, but yes, I want you to show your work on this so I know that you're using the correct volumes. So we recorded that our final volume was 16.5 milliliters, initially was 3.5 milliliters. So what that means is that we must have transferred 13.0 milliliters of acid into our flask. Okay, so now what we're going to do is we're ready to titrate it, meaning we're ready to add the base until we get to just that neutral color. So when I first add my phenolphthalein to my acid in the flask, anybody remember what color this solution will be? If you said clear, you are absolutely right. So then what we do is we fill a second buret with our base, and then we will record our initial volume just like we did before. Then we'll open the valve at the bottom and drop by drop we'll start adding our base, and we'll do that until we just hit the pink. Then we'll record the final volume, and then when we subtract those two numbers, then what we'll have is we will have the volume of the base that was added. Now when we do that, when we hit it at just that hint of pink color, we know that we are exactly at that point where the molarity or the concentration of our hydrogen ion is exactly equal to that of our hydroxide ion. Okay, we've reached that neutralization point. So what's actually really going on in there? Well, if I look at what I have in the contents of my flask down here, if I were to blow it up and think about what kind of ions are in there, I've got my indicator, my HIN, that just indicates my phenolphthalein, but I also have, because it's an acid, I have a bunch of hydrogen ions in there, okay? And again, why is it colorless when I add phenolphthalein? Because in the presence of an acid, my phenolphthalein will be colorless, okay? Then what I'm going to do is I'm going to add a drop of base from the buret. And notice right here, I've got the base in the buret. It's going to drop down in my flask, and let's see what actually happens when we do that. We drop it in, it finds a hydrogen ion, and what happens is that hydrogen ion and that hydroxide ion combine together to form water. Okay, is the solution still going to be colorless at this point? Sure it is. It's going to still be colorless because notice, I still have a lot more hydrogen ions. So I still have an acidic solution. So then what I need to do is I just need to continue adding my base drop by drop. So I'll go ahead and do that. Okay, there we go. Again, we made more water when we did that. Is the solution still colorless? Yeah, I still have hydrogen ions. So I'm going to need to continue adding my hydroxide ion. And again, at this point, it's still colorless. And what you have to do, as you know, when you're working in the lab, you have to be very careful to make sure that you're adding it slowly so that you get just to that hint of pink. So again, continuing to add it drop by drop, drop by drop. And lo and behold, as soon as my hydrogen ion equals my hydroxide ion, what I'm going to do is I'm going to get my hint of pink. At this point is where I would read my final volume in my buret, then I could subtract it, and then I could get the total volume that was added. This is a very, very accurate way of determining a volume that has been added to a particular reaction. Now, let me ask you a question. What if I accidentally added one more drop of hydroxide ion? What do you think would happen? Oh, darn it. Overshot the endpoint, made it magenta. I added too much base. Again, this is our tricky part of our lab.